Yes, guys. So the final part of this question, let me solve it. So taking these two ratios first, and then the second two, we will find out value of x1 and y1, and substituting those values of x1, and we have to find out sorry, this x1 raised power n. That we have to find out value of x1 raised power n and y1, and substituting those two values here, we will get this. We have to get this condition which is given to us. Okay, so that we have to prove here. So let me take these two ratios first, then B and C. Okay, from this first ratio we have, if I find out A, let me take C here. A upon C is equal to this equation. This is 1 upon n into x1 whole power n minus 1 divided by this value is x1 upon n into x1 whole power n minus 1 plus pi 1 upon a raised power n minus 1. Okay. Now, if I multiply this ratio by this one, so this will come in the denominator. What we get here? Here we will get this LCM. Without taking LCM, let me multiply this whole equation by this. We will get here 1 upon, this is x1, sorry, this is x1, this is x1 here. So x1 and this whole value and n whole power, if I multiply this to this one, this will be cancelled out. Only x1 will be the remainder, plus y1 into this whole value, so n into y1 into x1 whole power n minus 1 divided by a raised power n minus 1. Okay. This whole value n into x1 n minus 1 will multiply to this, it will be n into y1 into x1 n minus 1 divided by the same value. Now let me further solve it. This is 1 upon okay. Now here let me substitute some values. This is x1. Here it is plus n. If I substitute value of y1, the value of y1 here, y1 is x1 whole power n, or let me multiply this by x1 to both the sides. If I multiply this by x1, let me write n y1 into x1 whole power n minus 1 into x1 divided by x1. So this is a n minus 1 into x1. No change. It will be x raised power n, x1 raised power n divided by x1, take LCM. It will be x1 will come in the numerator. It is x1 upon x1 divided by x1, this is whole square, plus n into y1 x1 whole power n only. This is x1 into x1 power n minus 1. Powers are added when bases are same. So this is x1 and this is x1 raised power n minus 1. It will be xn minus 1. And the denominator is LCM, sorry, this an minus 1 is also there. Sorry, here it is an minus 1. If I multiply, if I take an minus 1 also here, then an minus 1 will be the combination of this also. But I have taken LCM. What LCM I have taken? x1 into an minus 1. So this x1 an minus 1 will come in the numerator, and both will come here also. This is x1 square into an minus 1. Now substitute the value of x1 raised power n minus 1. So let me substitute the value. That will be, in the numerator we have an minus 1 into x1 divided by, here if I substitute value of x1 whole power n is equal to an minus 1, it will be n into y1 one more into an minus 1. As from the second equation we have x1 whole power n equal to an minus 1 into y1. Substituting this value of x1 raised power n here it will be y1 into an minus 1, an minus 1 into y1. This y1 square after substitution we get here. Let me write this here, solve it here. So it will be, let me put it here. This is a n minus 1 into x1 divided by a n minus 1 is common. Both a n minus 1 is common to both. Okay, that means a n minus 1 has come. This is x1 square, I'm sorry, because by x1 already, by x1 square here. Because here it was x1 already, x1 came from this x1 and here is power n, so this is x1 square. X1 square plus this is n into y1 square. And a n minus 1 is cancelled out. What do we get? So from this is implied that this x1 square is n into y1 square is equal to this value. This is c into x1 upon a. Let me take this as third equation. Look at this third equation we have obtained from the first ratio. This is the third equation we have obtained. Now let me take the second ratio. This b upon this equal to, that is b upon 1 upon a n minus 1 is equal to c upon x1 upon n into x n minus 1 plus y1 upon a raised to the power n minus 1. This whole value, let me now solve it. So b upon c, again writing c inside and take this one, means that 1 upon a n minus 1 divided by, okay, this is n into x1 whole power n minus 1 plus sin y1 upon a n minus 1. Now in this case, if I take this numerator or denominator of numerator 1 upon a n minus 1 to this, we have to multiply by, let me write this 1 upon, this is n into this, n into a n minus 1 into x1 whole power n minus 1 plus this a n minus 1 is cancelled out. So this will be only y1. If I substitute value of y1, the x1 upon a n minus 1, okay, that can be substituted, or if I just write okay, value of x1, right, that can also be written down. So let me first multiply this. Okay, so that can be, so let me solve it further. N into a n minus 1, n into a n minus 1 into x1 whole power n minus 1, and if I multiply this by x1 and divide by x1 in the denominator, plus this is y1 as it is, because a n minus 1 I have multiplied to the denominator, so a n minus 1 of y1 will be cancelled out. Okay, of y1 will be cancelled out. So now let me further solve this. So this is x1 whole power n minus 1. If I write it in terms of y, so let me put it here, or solve it here. It will be b upon c, so we solve it in these numbers. It will be okay, n into, if I take LCM, n a n minus 1 into x1 whole power n, because x1 into x1 whole power n minus 1, and this x1, if I take LCM, this x1 will come in the numerator. This is x1, so we can here, that this is x1 into by 1. Okay, x1 into by 1. If I write here value of x1, which is x1 raised power n, x1 raised power n, that by 1 into an minus 1. Okay, so that can also be written, or by 1 is equal to xn, and xn take common, so xn minus 1 will take less common. So that is one of the solutions here. So y and by 1 upon, okay, n into xn minus 1 plus n into xn minus 1. I'm sorry, there is a question here. If I have taken this an minus 1, we'll see this value. So only this n by here, n xn minus 1, why I have taken this x1 upon n xn minus 1. Have I taken this? No. I'm sorry, I have committed error. Now let me again solve it. Simple one. But okay, some mistake has occurred. Let me take again. This is b upon c. Okay, this is 1 upon an minus 1. Again, I am taking b as c ratio because mistake has occurred. I have seen. This is x1 upon n into x1 n minus 1 plus by 1 upon an minus 1. This is an minus 1. Okay. If I multiply this and taking this n x1 minus 1 LCM into an minus 1 LCM, if I take in the denominator, that will give us, let me not multiply by this, but by if I take LCM, what LCM an minus 1 and into n into x1 whole power n minus 1, that will be x1 plus this by 1, x1 plus by 1 into n into x1 whole power n minus 1. Okay, that will be the LCM if I take this is n into x1 whole power n minus 1. We have taken these two LCM, so this will come here, an minus 1, sorry, this an minus 1 will also come here, an minus 1 into x1, this into this, okay, and this will come in the numerator. So what do we get here? So we get, okay, in the denominator we have already 1 upon an minus 1, so this an minus 1 is cancelled out. We can so we will have in the numerator n into x1 whole power n minus 1 divided by these two values, n minus 1 into x1 plus n into by 1 into x1 whole power n minus 1. Now if I multiply this by, because this is x1 whole power n minus 1, multiply by x1 divided by x2, no change. Now take then x1 LCM, so x1 will come here, the x1 is here. Now let me again write it down. So this is, let me write it here. Okay, it will give us, we write and x1 whole power n minus 1 divided by this value to be n minus 1 into x1. Now after taking LCM, this x1 will come in the numerator. This is into x1. This will come here and this x1 multiply to this and this x1 also multiply this. This will be x1 square LCM. x1 will multiply to x1, x1 square. So this is n into by 1 and this value is x1 whole power n. Only because x1 whole power n minus 1 into x1, that means x1 whole power n. Okay, now, so this is the solution. But now if I substitute value of x1 whole power n equal to this, that will give us further solution. And in the numerator we have n into x1 whole power n only divided by, now this an minus 1 into x1 square, this is x1 square, plus here x1 value is n into by 1 is already there, this is a n minus 1 into by 1. in the denominator we have. It will give us n into, now substitute value of x1 in the numerator again. This is an minus 1 in the numerator into y1 into n. Value of x1 whole power n in the numerator. With that also we have substituted an minus 1 into y1 into n is already there, divided by an minus 1 into x1 square. So this value is y1 square into an into y1 square into an minus 1. If I take an minus 1 common, both in denominator and numerator, that we can take out. What do we get? Let me write it here again. All let me write here because this value we have obtained. No change. Let me write it here. So this will be b upon c is equal to an minus 1 if I take in the, okay, let me first write y1 into n divided by an minus 1 I have taken common in the denominator. So we have f1 square plus n into y1 square only. This an minus 1 cancel out. The second equation. Now then we have to solve these two equations. This is the first equation. Second equation we have obtained x1 whole power n minus 1. x1 square plus n into y1 square. Same equation we have again obtained is equal to c upon b. This is okay, c into n c by 1 divided by b. This we have obtained. This is c into n into y1 n c by 1 n c by 1 upon b equal to this value. Okay. These are two equations. Let me solve these two equations. Then final solution will be obtained. So let me solve these two equations. What these two equations say. So after solving these two, if I subtract this from this one, because left hand sides are equal, right hand side will be equal. So let me equate the right hand side. If the left hand sides are similar, right hand side will also be similar. So cx1 divided by a is equal to n into c into y1 upon b. Okay, from third and fourth. This is from third equation and fourth we have obtained. This third and fourth, we see the right hand side will be equal of both the equations because these two are same. x1 square plus n y1 square, x1 square plus n y1 square. So right hand side are equal. So we have equated them. So here c cancel out. So what is x1 here? So we see x1 is equal to, okay, this x1 equal to a n into a upon b into y1. Okay, this value. If I substitute this value of x1, because it has come in x1 y1 both. So we have to find the value of y1 or x1. Let me substitute this value in second or first, and let me find out what is the value of y1. So if I substitute this value in second, okay, or in the first one, that doesn't matter. That can give us value of this is y1. So value of y1 we have to find out. So let me substitute this value here in second equation because y1 then x1. So in terms of y1, if I substitute value of x1 from third one, substituting this value of x1 in fourth, from fourth, after substituting this value, substituting this value of x1, we get x1 is this is square n square a square upon b square into y1 square plus n into y1 square. Okay, so equal to n into c into y1 upon b. y1 take common from this equation. So we get here y1 square. If I take common, we get n square a square upon b square equal to n only. Okay, it will give us n into c into y1 on b. If I take b LCM to n b square and a square, n square common, a square plus b square, we have the obtained. Okay, this b will come to the side, okay, that is there. If I write it as n b square, so this 1 by 1 is out, and this by 1 is cancelled out 1 by 1. Okay, so now let me solve this equation. Here let me solve it. If I solve it, so by 1 into it is b square LCM, n square into a square plus n into b square. Here n is common, so I have taken that n common equal to this value nc upon b. nc upon b. So this will give us here one common n. So n, if I take common, it is n into y1. In the bracket we have n a square plus a square plus n into only b square and because n are taken common, so this is b square divided by b square equal to nc upon b. 1 b cancelled out. nbc will give us there. So y1 equal to, if I write y1 equal to, therefore value of y1 is b and c. b and c sorry, this n and cancelled out because n I have taken common. So this n and n is cancelled out. More n. Because 1 n I have taken common, so n and cancelled out. So by 1 is equal to not n but bc only. This will cancelled out, only bc upon. Okay, this is n a square plus b square. Okay, this is value of by 1. Okay, so by 1 here we have obtained. Let me write it here. BC, if no mistake is committed, BC, okay, and upon n a square plus b square. Okay, no change. Now let me substitute this value of by 1 in this case. Okay, so it will give us x1 value. Therefore, substituting this value to find out value of x1, what we get, that's what x1 equals in this equation. And capital A upon B into by 1. That means BC and A into this is BC upon and a square plus b square. So 1b and b cancel out. All that 1b and b cancel out. So we get n cancel out. So we get what? I'm sorry. What is that? This n is not cancelled out because this n is not like this. This is n a square plus b square, value of y, bc upon n is equal to b. So n cannot cancel out, only b will be cancelled out. This is ac, n into ac divided by n a square plus b square. This is value of x1. So x1 equal to nac divided by na square plus b square. This is value of x1. That is value of y. Now, if I have to substitute value in this equation, I have to have x1 whole power n. Find out this. Therefore, x1 whole power n is equal to n raised power n, a raised power n, c c raised power n divided by n a square plus b square whole power n. This is value of f1 whole power n, and by 1 is this value. So substitute these two values in this equation second. Okay, so let me substitute these values. So substituting these values in second equation. Substituting these two values of f1 and y1 in this equation. Let me write here, substituting these values of x1 whole power n and y1 in second. We get all this to find out the condition and find out value of x and y1 and substitute in this. After substituting the point, then it can give the condition to us. So let me write, this is a n minus 1 into y1. Y1 is this value. This is b into c divided by n a square plus b square is equal to x1 whole power n, which is this. This is n whole power n a n c n divided by n a square plus b square whole power n, value of x1 whole power n, cross multiply them. So we can get this, and c, this 1c will come to this, it will be n minus 1, cc cancel out, and take to that side it will be minus 1 power. And this, if I take here and this divided, it will be a n into b, this b into multiplication n a square plus b square whole power n minus 1, because this n power and this 1 power. This 1 power will come in the numerator, that will give us n minus 1 power. This is equal to n whole power n a whole power n c raised power n minus 1. Now let me check whether this is the condition. The condition here n, okay, a n c n minus 1, and this whole equal to a raised power n minus 1 into b into n a square plus b square plus n minus 1 power. Same condition is obtained. This is the very lengthy question, but solvable very easily. Systematically, we have to find out value of x1 by 1 and substitute the value of x1 by 1. If any error is committed, then it may take time. So please solve it with patience, and the question is solvable. There is no doubt about this. But it takes time. So it has been proved that okay, this condition is true. And n c n minus 1 is equal to a n minus 1. Sorry, this is a n minus 1 into b, right, into n a square plus b square whole power n minus 1. Same question, same condition has been applied. So this is how we have to solve these questions. Now next question. What are the other questions? 7th and 8th question let me solve. The question number 7th and 8th are also there. The question number 7 says, it says find the equation of the normal to the curve this, okay, at the point where it cuts the axis of x. So first of all, let me find out that point. Question 7 says the curve is y into x minus 2 into x minus 3 minus x plus 7 equal to 0. Now it says that it cuts the axis of x at the point where it cuts the axis of x, So at the axis of x, y coordinate is 0. At the point it cuts the axis of x. Okay. We find out normal, because we normal to the curve at this point. So the point is, so at the x-axis, let me write here, at the x-axis of x, y equal to 0. Y coordinate is 0. Let me write here, at the axis of x, y coordinate will be 0. Y equal to 0. if I substitute in this equation, we will get value of x, because we always find out the point after substituting in the original equation. Substituting y from first, this is first equation. So y equal to 0, substituting y equal to 0 in first, we get the point, this is 0, y into this 0, minus x plus 7 equal to 0, or x equal to 7. So point is what? 7 and 0. Y coordinate 0, x coordinate is 7. At this point, we have to find out what is the equation. For that, let me differentiate the first equation. Differentiating first with respect to x, we get. Differentiating first with respect to x, we get. What do we get? Okay. So that is, let me find out dy dx. The ddx of this equation, let me multiply this. This is nothing but x square minus 5x plus 6. So multiply this minus 2x and minus 3x minus 5x. Multiply minus 2 into minus 3 minus plus 6. Okay, so that is there. Minus x plus 7 equal to 0. So if I differentiate this equation, after differentiation, you will get this by product rule. Now, this product rule will give us, let me first write x square minus 5x plus 6 as it is, into dy dx, the derivative of y. Now, plus y as it is, derivative of these two, twice x minus 5 minus 1, derivative of x1, x minus 1 equal to 0. So, value of g by dx will be what? No, okay, so value of dy dx, let me first solve it. This one will give us 1. Okay, after substituting the value, let me, okay, this equation will be minus 1, that means plus 1. This is minus y into y set to minus 5 divided by, okay, these two are taken together, this one will be positive, this is negative, divided by this whole value, that means x square minus 5x plus 6. Substituting value 7 and 0, d by dx at the point 7 and 0, that means x 7 and y 0.